calling video range.
A space projectile has just left the planet Earth.
What can we do? Our only chance is to flash between them before they meet.
Hello everyone, my name is Bob, and this is Space Colonization with Bob number 4, in which I start talking about space infrastructure, primarily robotic industrial infrastructure. Now on Earth we have this very large and complex, essentially self-replicating system in which you put raw materials in one end, coal and ore and whatever, and put resources in one end, you get finished products out the other. And then when your machines to do that break down, you use machines to build replacement machines. You build tools to build tools to build tools, and so on and so on, for as long as there's a market for those products or a need for those products. And that whole thing has been developing over essentially thousands of years, all the way going back to the guys in ancient Greece who traded wine and olive oil, until the present day. And we're going to need to, if we're going to colonize space, we're going to need to have that sort of process started. In other words, we're going to have to take raw materials from where they are and turn them into things that we're going to need on the moon or on other celestial bodies. That problem is magnified by the fact that without the products of those machines, without the products of that industrial infrastructure, essentially we can't live in space. I mean, on the Earth, if everything goes to hell, you could go run out in the woods in your skivvies and eat berries or whatever. In space, that's not an option. In space, if you don't have industrial infrastructure of some kind, you either have to go home or die. Mostly that's going to be a robotic infrastructure, because human beings aren't made to go to space, which means they have to be kept protected from the environment they're in. I mean, that's not, in a sense, that's not too completely dissimilar from the process that the life went through, having to go from the oceans, the seas, up into land, onto land, which was a totally hostile environment at that time. But this is actually probably a little bit harder, because we're going. That was a situation where we had where life at that time had a couple things it had to overcome. We've got a whole slew of things we have to overcome. I mean, it's a vacuum, it's radiation. In fact, that raw materials aren't in the same forms that there are on Earth. So I'm in Space Colonization with Bob. I am starting a series on robotic space infrastructure, or primarily robotic. It's not entirely robotic, but primarily humans are going to play a part. But primarily the folks, the things that are actually going to be doing the work in a physical sense are going to be mostly robots. And the things I'm going to focus on the moon first off, and the things that we're going to need to get from the moon to lock into this structure that we're building. First, we're going to need oxygen, and that's probably going to be the easiest thing to get. Oxygen. I mean, my understanding is you basically cook off some lunar regolith to a high enough temperature, and it will give off oxygen. We need oxygen. We need water, which presumably is water at the poles. The big first really tough hurdle is we're going to need aluminum. Aluminum is a really pivotal smelting aluminum from lunar materials without significant imports from the Earth. That's a pivotal technology. If we have it, then all sorts of things open up. If we don't have it, we got a problem. So getting the ability, which we don't have yet, to make aluminum from indigenous materials without significant imports, that's going to be a pivotal technology. And if we're able to do it, that means we have things like, rocket parts, spacecraft parts. We have spacecraft fuel, because you can use aluminum as a fuel in solid rockets and in metal hybrid rockets as a construction material. Pretty much to begin with, if we are able to do this, pretty much everything that we need from a structural point of view, we're probably going to try to be doing it with aluminum, because we know that steel is going to require the import of carbon, which at some point may not be a problem, but probably in the early going that's going to be a problem. We are also going to need hydrogen from the water to fuel spacecraft to go to the asteroids. So let's imagine. Also, I'm filming this in this weird way because I want to have visual aids. So you may see me kind of staring at the screen here because I want to have visual aids to what I'm talking about. Okay, so let's say we've got a go ahead we're going to colonize space. We got the budget. We're going to set out to do it. The first thing we're going to need to do is go to the South Pole and see what condition that water or ice or other hydrogen products are in. Now, if it's something that we can just scoop up and put it in a kettle and boil it, that's great. It may be hard as a rock. It may be a couple meters under the surface. So we need to find out where it is, what condition it's in, and what kind of techniques we're going to need to extract it. Now we're sending a mission to the South Pole. I think they said it was 2017. The Resolve mission. I have some questions about that mission, which is apparently the rover, or whatever it is going to run on solar power, which means it's not going to be able to land, at least, in a permanently shadowed location, which kind of cuts down on the odds of finding hydrogen, I would think, because direct sunlight is kind of in space is kind of an enemy of having frozen water. So I'm kind of have questions about that. Maybe someone could explain that to me to my satisfaction. But for whatever reason, they're going to the South Pole, but they're going to the South Pole in an area that has some sunlight exposure so that they can run off solar power. It could be partially because they didn't use RTG, radio isotope thermoelectric. My tongue is not working. An RTG, yeah. The reason why they probably didn't use RTG, or why they may not have used it, is because we have a plutonium shortage. So that may be why they chose not to go with an RTG. I can't believe a radioisotope thermoelectric generator. Yeah, okay, RTG. Had a slight brain fart. These things happen. Radioisotope thermoelectric generator. Yeah. So I have some issues about this mission that's coming up, Resolve mission, as to whether they've made too many compromises on that. Because if you land in a suboptimal place for finding water or hydrogen, and then you don't find any, it doesn't really tell you much. You need to land in the best possible spot for it, and then if you don't find anything, then you know that something's gone wrong. In any case, water on the moon is a game changer. Without water on the moon, we may not be able to do colonization, at least on the moon, at all. So before we put any kind of serious hardware on the ground, we have to, send a probe and then follow-up probes as needed to the South Pole to find out what form the hydrogen and or water is in, and in what way it will be able to be extracted. So that's one. Two is we're going to need to send probably several materials labs to various aluminum-rich places on the moon to experiment with means of extraction, and also to test, what the purities of the metals are in those particular spots. So you have to just sample the regolith, the soil, for its aluminum content, and then you have to experiment with ways of turning that dirt into actual aluminum, pieces of actual aluminum that we can do something with. So we may have to send multiple probes of that type. Okay, and as far as actually getting aluminum on the moon, we have a few problems that we have to overcome. First off is the ore. Earth is very fortunate in that it has the mineral bauxite, which is a very enriched source of aluminum. Bauxite is formed by water deposition. It's not going to exist on the moon. However, there are some minerals on the moon which should work almost as well. That's problem number one. But we're going to probably need to find those soils on the moon that are absolutely best for that, because again, we don't have bauxite. So we have to send a materials lab, or several materials labs to the moon to check the aluminum content of various soils in various locations. That's part one. Part two is that creating aluminum from aluminum ore on the Earth requires a mineral which we have never found outside the Earth in the solar system. That's cryolite, a fluorine-rich mineral. Cryolite is fairly rare even on Earth. We've never found it anywhere else. We're not going to find it anytime soon on the moon, even if it's there in some location that's so bizarre that we probably weren't going to find it anytime soon. So we're going to need to find a way to, or we're either going to need to import fluorine from the Earth, or we're going to need to find a way to create aluminum from aluminum-bearing ores without using fluorine. Now you might say, okay, well, we'll just bite the bullet and say we're going to import our fluorine from the Earth. The problem is that even if you do your best to try to recycle that fluorine, you're still going to lose some. It's not going to be 100% recyclable. Probably with this sort of thing, it's even going to be less than it would be with something else. So you're still going to have to be importing fluorine from the Earth on a regular basis. It's not a really good. That's not the optimal solution. There is possibly another solution, which is, I don't get any endorsement money from Dr. Pepper. I just drink it. Okay, you're familiar with distillation, right? You distill, let's say you make some wine and you want to turn it into hard alcohol. You heat it up, and the alcohol preferentially vaporizes before at a lower temperature than the water in the wine will. So you extract the alcohol from the wine by distillation. And you could, in theory, you do the same thing with aluminum. The problem is that the vaporization temperature of aluminum is real high. How high is it, Bob? Let's find out. God bless Wikipedia. Okay, aluminum starts to vaporize at over 2,500 degrees Celsius, over 4,500 degrees Fahrenheit. Problem with that is above the melting temperature of just about anything. So you have to find a way to contain this heated material in such a way that it doesn't melt the container it's being heated in. But in theory, you could actually vaporize the aluminum and use various methods to separate that out from the other materials that are in the what you're vaporizing, and create pure aluminum. And this process is also going to be, you can also see this working into sort of a general method of extracting regolith for a wide variety of materials. For instance, if you, I talked about extracting oxygen from regolith by heating it. Well, you heat it, that drives off the oxygen. Oxygen is the enemy of making pure aluminum because aluminum bonds to oxygen very fiercely. So the first step in making aluminum is trying to figure out a way to separate it from the oxygen. So you heat up the regolith, that drives off some part of the oxygen, not all of it, but some part of it. Then you get that'll form like a metal ceramic slag type material. You collect these bits of slag, and then you grind them up because they're going to be like little hockey pucks, and then you do the process again at a higher temperature. There are various other things that are going to melt off before or vaporize before the aluminum does, and you can either separate those out and use those materials as well, or just get rid of them. Like for instance, iron. Iron's going to vaporize at a lower temperature. But there's plenty of other ways to get iron on the moon, so you may not even bother to try to collect the iron. So you would what I'm visualizing is basically a large crucible, and the first step is you just fill that crucible up with regolith. Focus light from a really big mirror onto the regolith. Heat it up to the temperature at which the oxygen starts getting released. You collect the oxygen. You grab the slag, break it up, fill up the crucible full of slag, and again focus a beam on the middle of it. The slag itself should, the broken up slag bits, should insulate the container enough to where it's not going to melt, assuming it's made out of sufficiently heat resistant materials. It's not going to melt when you start vaporizing the slag. And then you deposit the vapor from that at the point at which the aluminum starts to come off. You deposit that vapor onto a surface, and you take that. It still might not be pure aluminum, and then you repeat the process, and at some point you're going to get pure aluminum. Not a very efficient process, but it would be a process that would actually work on the moon without requiring imports. And it's a process we're going to be doing in part anyway, because we're going to be needing to heat up the regolith pretty considerably just to get the oxygen out of it. So we begin to see a method by which we could extract aluminum that very much dovetails with other processes we're going to want to be doing on the regolith. Extracting oxygen, possibly extracting other materials. Now I'm not a chemist or a physicist or a material scientist. I don't know what pitfalls may devolve from this plan, but it's the best plan I can come up with at this point, which is on the surface of the moon, create gigantic inflatable, essentially, or inflated with foam so that it retains rigidity even if it's punctured, inflatable mirrors that focus sunlight, a large amount of sunlight, onto a very small spot, and that spot first melts and then finally vaporizes. You take the vapor off that and do what you need to do, and presumably you could have the distance between the target and the mirror change depending on whether you're making oxygen or aluminum. You could probably use a larger focal area for oxygen and then a smaller one for aluminum, because obviously if you make the area of vaporization for the aluminum too large, it'll simply melt the container, which is not good. So getting back to what I was saying is that we needed to send some materials probes. Just making sure we're still recording. Yes. Just send some material probes to the moon first. Figure out what we can do with the resources there, what form the water is or hydrogen is on the South Pole, and test out some methods for extracting oxygen and aluminum from the regolith. That's part one. Part two is you basically land some construction equipment, some robotic construction equipment. You probably get away with, you're probably going to need to have a dump truck with a filter on top, so you can pour regolith into the dump truck, and the big rocks will be caught. Because what you're going to want to use, the materials you're going to want to be using for just about everything to start off with, is going to be very fine lunar dust, not rock. So basically, you have a dump truck, a backhoe with a dozer attachment on the other side, and a very small lightweight crane on it, and a sintering machine, a solar sintering machine. And piggybacked on the landing for the dump truck, you can also include a magnetic trailer, which is basically something you tow behind the dump truck that has a strong magnetic field. It will pick up iron off the surface, so you don't have to. If you want cast iron, you don't have to really go through a whole lot of hoops to do that. You just, run a magnet. You have a little wheeled vehicle, run with a very, very large magnet on it, tow it behind the dump truck, and pick up iron fragments that way. The three main construction equipments we're going to require to begin with. One, the dump truck with the magnetic cart to tow behind it to pick up iron for those relatively few things that we're going to need iron for. We're going to need the backhoe / bulldozer / crane, and we're going to need a solar sintering machine. What is sintering? Sintering is the bonding together of materials at lower than their melting temperature. So you can think about if you have a bunch of ice cubes in a glass of water, the ice cubes fuse. That's sort of roughly a parallel of what goes on. What it does is it bonds materials together like melting them, but without having to actually melt them, without having to get that temperature. So basically that would be essentially a very large Fresnel lens on a cart. It focuses on a particular spot and centers that area. Yes. So what you have there is essentially a 3D printer writ large. So when you're going to want to go to build construction projects, you're going to want to have shelter. So what you would do is lay down a fine layer of lunar dust, center it in the pattern that you want, put on some more another fine layer of lunar dust, do the same thing over and over again until you have your structure. And you're going to want to have shelter not simply for people, but also for machines. If you're having a very severe solar storm, you probably don't want to have your machines out running around if you can have them under shelter. So shelter is good for a wide variety of things, not simply because humans are going to need radiation shelter. You're going to need the next step after the basic exploration of the materials and processes will be means of creating a shelter. The pickup truck thing, the bulldozer / backhoe / crane, and the sintering machine. So that'll get us started as far as building shelter. Now you may be seeing a picture of a little 3D model I've done of this equipment. And you may notice there's a meter bar there, which indicates that the vehicles are not that large. That's a trade-off we'll be doing. If we want to get the shelters done really quick, we're going to need big, heavy construction equipment that's going to be a pain in the ass to get to the moon. If we don't care about wasting a year or two building this thing, we send relatively smaller construction equipment. They'll still get the same job done, but it's less launch weight. So, okay, I think I've probably gone over as much. This is going to be sort of a series of the next several episodes. Again, probably gone over as much for right now as I can. So if we let's say that the world just decides we're going to colonize space, we're going to do it. We're going to devote the resources we need to get that done. The very first things we're going to need to do are send those probes that I mentioned, and send construction equipment to build shelters. And then we're going to have to send a bunch of other things, which will be topics for next episodes. So until next time, hasta la vista. Adios.